Last time, we sailed all the way out to the edge of the universe and let the ship drift in the dark past the last faint light. Tonight we are not going to travel through space at all. Tonight we are going to travel forward, through time, far past anything that has a name, to see what the universe becomes after the stars are gone. Because here is the gentle, astonishing thing that most people never hear. The night sky you grew up under, the sky full of stars, is not the normal state of the universe. It is a brief and beautiful morning. The stars are temporary. Every one of them is burning through a finite supply, and one by one, over spans of time that make a human life look like a single breath, they will all go out. And yet when the last star finally dies, the universe will not be empty. It will still be full of things, strange, patient things, glowing embers and dark, dense stars, and the deepest objects of all, waiting in rooms we have barely begun to imagine. It keeps going far longer after the stars than the stars themselves will ever last. So tonight we are going to walk forward through those rooms, slowly, gently, one at a time, and watch the lights go out, and see what remains in the dark. If these long, quiet journeys help you sleep, subscribing is the easiest way to drift forward with us again. Settle in. We are going a very long way from tonight. Before we go forward, let us be honest about where we are standing, because it is a stranger place than it feels. The universe is about 13.8 billion years old. That is an enormous number, far older than the Earth, almost unthinkably older than you, and it is tempting to assume that something so old must be near the middle of its life, or perhaps even getting on in years, the way a 13-billion-year-old anything surely should, but that intuition is completely wrong, and the truth is one of the loveliest facts in all of science. The universe is not old. The universe is extraordinarily, almost embarrassingly young. We are not in its middle age. We are in the first few minutes of its morning. Astronomers who study the deep future divide the whole life of the cosmos into great long ages, and the age we live in has a beautiful name. They call it the stelliferous era, which simply means the age that is full of stars. It began a few 100 million years after the Big Bang, when the first stars caught fire in the dark, and it will end when the last star burns out. And here is the part that is hard to hold in your head as you lie there in the warm. That age of starlight, the entire era in which stars exist, runs from roughly 1 million years after the beginning to about 100 trillion years after it. 100 trillion years, and we are standing at 13 billion. We are not 1% of the way through the age of stars. We are not 1/10 of 1%. We are standing in the first 10,000s of 1% of it, right at the very start, in the first soft light of the first morning, when the sky is as full and as bright as it will ever be. You were born in the morning of everything. Every human being who has ever lived was born in that same narrow band of brightness. The brief window when the universe is lit. We think of the night sky as eternal, as the permanent backdrop against which everything else happens. But the stars are the fireworks, not the sky. They're the early, brilliant, temporary part, and we got to be here for it. Look at what that means for the sky above you right now. Every star you can see with your eyes is a furnace, converting itself, gram by gram, into light. The sun does it. It is burning through 600 million tons of hydrogen every second to make the light that warms your face on a clear day. And even at that rate, it has enough to keep going for billions of years more. The brightest, hottest, bluest stars are the most extravagant. They blaze 100,000 times brighter than the sun, and they pay for it by burning out in only a few million years, gone almost as soon as they are lit. The faintest, smallest stars are the misers. They hoard their fuel and burn so slowly that they will still be glowing long after the sun is cold. But all of them, the spendthrifts and the misers alike, every single star and every single galaxy is doing the same thing. There is no star anywhere that is refilling its tank. Once the hydrogen is gone, it is gone, and the universe as a whole has only so much of it. The great clouds of gas that make new stars are being used up and not replaced. Each generation of stars locks some of that gas away forever inside dead remnants that will never burn again. So the sky is not only temporary, it is already very slowly beginning to dim. Right now, across the whole universe, stars are being born more slowly than they were billions of years ago. The peak is behind us. The great age of star formation, what astronomers sometimes call cosmic noon, happened around 10 billion years ago, when the cosmos was lighting new suns far faster than it does today. We were born a little after the party's brightest hour, in the warm, long afternoon of it, when the lights are still on, but the rate of new ones has quietly begun to slow. None of this is sad, not really, not tonight. It is the opposite. It is the reason the sky is precious. You happen to be alive in the one era of the entire universe when there is light to see by, when the night is full of distant fires, when a person can step outside and look up and see 10,000 other suns. There will come a time, very far from now, when no creature anywhere could do that, because there will be nothing left to see. We are not living in the leftovers of a brighter past. We are living in the brightest moment there will ever be. So hold the sky for a moment, as it is right now, full and bright and busy with starlight. Hold the warmth of it, because from here we are going to start walking forward, away from this morning into the long afternoon and the longer evening, and we're going to watch, very slowly and very gently, as the lights begin, one by one, to go out. And the first to go will not be the small, patient ones. It will be the biggest and the brightest, the stars that burned so hard they could not last. The dimming does not happen all at once, and it does not happen evenly. The stars go out in an order, and the order is almost the reverse of what you might expect. The brilliant ones leave first, the humble ones inherit the sky. Think of it like a great hall full of candles of every size. Someone lights them all at once. The fattest candles, the showy ones, burn with the biggest flames, and everyone admires them, and they are the first to gutter and die, because a big flame eats its candle fast. The thin small candles barely seem to be burning at all. You could almost overlook them, and those are the ones still glowing, quietly, long after the grand ones are cold puddles of wax. The universe is exactly like that. The massive blue stars, the spectacular ones, live fast and die young. The very biggest last only a few million years, a blink before they collapse and explode. Stars like our sun are middle of the road. They get something like 10 billion good years. And then there are the small red ones, the red dwarfs, and they are the patient inheritors of all the long ages to come. Let us follow our own sun first, because its fate is gentle, and it makes the rest easier to picture. In about 5 billion years, the sun will finish the hydrogen in its core. When that happens, it will not simply switch off. It will swell. It will become a red giant, bloating outward until it is large enough to swallow the innermost planets, blowing a deep angry orange across a sky that by then will have no one left on Earth to watch it. Our world will be scorched bare. The oceans will be long gone. And then the sun, having puffed off its outer layers into a soft expanding ring of coloured gas, will settle down into what it will be for the rest of time, a white dwarf. Hold that object in your mind, because we are going to meet a great many of them tonight. A white dwarf is what is left when a star like the Sun has finished. It is the burnt core, packed unbelievably dense, a whole star's worth of matter crushed down into a sphere about the size of the Earth. It does no fusion anymore. It makes no new light. It simply glows. White hot at first, with the leftover heat of its long life, and then over enormous spans of time it cools, like an iron taken off the fire, still warm for a while, then merely warm, then cold. So that is the Sun, gone to a slowly cooling ember a few billion years from now. But the Sun is not one of the patient ones, the truly patient stars. The ones that will define almost the entire Age of Starlight are the red dwarfs. Red dwarfs are small, cool, dim stars, far less massive than the Sun, and they are everywhere. About 3 out of every 4 stars in the universe is one of these little red embers. You cannot see a single one of them with your naked eye. Not one, even though they vastly outnumber every star you can see. They are simply too faint, but what they lack in brightness they make up for in sheer, astonishing endurance. A red dwarf burns its fuel so slowly and stirs itself so thoroughly that it can keep going not for billions of years like the Sun, but for trillions, tens of trillions. The smallest of them will still be quietly glowing their deep red glow long, long after every sun-like star has gone dark. So picture the far future of the galaxy, tens of billions of years from now, then hundreds of billions. The big blue stars are ancient history. The sun-like stars are mostly white dwarfs now, cooling quietly in the dark, and the galaxy has turned red. The only stars still truly burning are the little red ones, scattered thin across a sky that has lost its blue and its white, and kept only its embers. The Milky Way, which is a blaze of mixed colours tonight, would by then be a dim, red thing, beautiful in its way, but fading, a hall where almost all the candles have gone out and only the smallest still flicker. And even those will not burn forever. Nothing does. The red dwarfs are the most patient flames in all of creation, but patience is not eternity. One by one, across spans of time that dwarf the entire current age of the universe many times over, even they will exhaust the last of their fuel. They do not explode. They do not make a grand exit. They simply fade, contracting and dimming, cooling toward the same quiet darkness as everything else, until the very last and smallest red dwarf in the entire universe gives up the last of its light. When will that be? The physicists who study this have done the arithmetic, and the answer is a number that is almost impossible to feel. About 100 trillion years from now. That is when the Age of Starlight ends. That is the last sunset, not on one world, but everywhere, in every galaxy, all at once, across the whole cosmos. And the strangest part is what happens the moment after. Because when that final red ember fades and the universe goes truly dark for the first time, it does not become empty. It becomes something we have no word for. A sky with no stars and yet still full. Let us stand at that moment for a while, because it is one of the great thresholds in the whole life of the universe, and almost no one ever thinks about it. 100 trillion years from now, The number is so large that the only honest thing to do is admit you cannot picture it, and then sit with it anyway. The current age of the universe, the whole 13.8 billion years from the Big Bang until tonight, would have to repeat itself more than 7,000 times to add up to 100 trillion years. Everything that has ever happened, the forming of galaxies, the birth and death of countless stars, the slow making of planets and oceans, and the rise of every living thing, all of it fits into a tiny sliver at the very beginning of the Age of Starlight, and we're talking now about its very end. By this point the universe has changed beyond recognition, but it has changed gently, the way a fire dies down. There were no catastrophes, no great explosions marked the end of the stars. They simply ran out, the way a long evening runs out of light, imperceptibly, until you look up and realize it is dark. The last star to shine anywhere is a small red dwarf, somewhere out in what was once a galaxy, although by now the galaxies themselves have changed. The expansion of the universe, the same patient expansion we followed to its edge last time, has carried the other galaxies so far away that they have long since vanished from any sky. A creature standing on a world around that final star, if any creature could exist there, would see no other galaxies at all, just a local dark, and its own dim red sun, the last fire in all of creation. And then that sun too begins to fade, its deep red light grows dimmer and redder, and dimmer still, sliding down through colours that have no names, until at last it slips below the faintest glow the eye could catch, and goes out. That is the final sunset, not on a planet, on the universe. For the first time since the very first stars caught fire, 100 trillion years before, there is no star burning anywhere. The great Age of Starlight, the era that contained everything we've ever known or imagined, the only era with suns and warmth and light to see by, is over. And here is where almost everyone's mental picture of the future is simply wrong. We tend to imagine that the death of the last star is the end of the story. The lights go out, and then there is nothing, an empty black forever. It feels like the natural ending, but it is not what happens. The death of the last star is not the end of the universe. It is barely the end of the beginning. Because the universe at this moment is not empty at all. It is crowded. It is crowded with everything the stars left behind. Think about what 100 trillion years of star death actually produces. Every star that ever lived and died left a corpse. The sun-like stars left white dwarfs, those Earth-sized cinders packed dense and cooling slowly in the dark. There are countless trillions of them now, far more than there were stars shining tonight, because every generation added to the pile. The biggest stars left even stranger remnants, neutron stars, the crushed cores of supernovae, each one a city-sized ball so dense that a single spoonful would weigh as much as a mountain, and the very biggest left black holes, about which we will have a great deal to say. There are the failed stars too, the brown dwarfs, objects that never quite gathered enough mass to ignite as true stars, drifting cold and dark, and there are more of those than anyone can easily count. And there are the planets, the moons, the comets, the rubble, all the cold leftover matter of 100 trillion years of cosmic history, still out there, still drifting, in a sky that no longer has any light to show it. So the moment the last star dies, the universe is not a void. It is a vast dark room absolutely full of objects, embers and corpses and cinders, dense and patient, scattered through an enormous dark. The lights are off. But the room is not empty. The room is more full of stuff than it has ever been. The astronomers have a name for the age that begins here, when the last star is gone, but the dead stars remain. They call it the degenerate era, and that word is not an insult. It refers to the strange, crushed state of the matter inside those dead stars, a kind of matter that does not behave like anything you have ever touched. The degenerate era is the long dark age of the corpses, and it lasts a very, very long time, far longer, in fact, than the entire age of starlight that came before it. So do not grieve too hard at the final sunset. Yes, the warm light is gone, and it will not come back the way it was, but the universe is still here, still busy, still full, and now we are going to walk out among the embers and see what glows there in the dark. Because a dark, it turns out, is not as dark as you would think. Step into the degenerate era with me, and let your eyes adjust, the way they do when you walk into a dark room at night and slowly the shapes begin to appear. At first it seems like total blackness, no stars, no galaxies in the sky, because they've all receded beyond seeing, just an enormous, silent dark. But as you wait, and as your eyes find the faintest light, the room begins to fill with the gentlest glows imaginable, scattered far apart across the deep. Those glows are the white dwarfs, the cooling cinders of all the sun-like stars that ever live. When a star like the sun first becomes a white dwarf, it is fiercely hot, hotter than the surface of the living sun, and it shines a brilliant white. But it has no fire inside to keep it warm. It is only coasting on stored heat, and across the immense spans of the degenerate era it cools slowly, patiently, the way a great stone wall holds the warmth of the day long into the night, and then, by morning, is cold. A white dwarf takes an almost unimaginable time to cool completely. The universe today is far too young for a single one of them to have finished. Not one black dwarf, as the fully cooled cinders are called, exists anywhere in the cosmos tonight, because there has not yet been enough time for even the oldest white dwarf to go cold. But in the degenerate era, there is all the time in the world, and more. So the white dwarfs glow, fainter and fainter, sliding from white to yellow to a deep, dull red, and then at last to the faintest possible warmth, and then to nothing the eye could ever see. One by one, over quadrillions of years, the cinders go cold. But while they still glow, even faintly, the universe is lit, not brightly. You could not read by it, but it is not nothing. A sky full of cooling white dwarfs is a sky with 1,000,000 pale points in it, each one a dead star giving back the last of its long life. It is the universe's second. Dimmer light, the glow of embers after the great fire has gone out. And there are other lights in the dark, rare and brief and lovely. The brown dwarfs are out there, the failed stars, cold and dim and far too small to have ever burned. There are vast numbers of them drifting through the dark, and every so often, across the long quiet ages, two of them happen to drift close enough to collide. When they do, something wonderful happens. Their combined mass is finally enough to ignite. For a brief moment, a few trillion years perhaps, a brand new small star flares to life in the darkness. A single point of true starlight in a universe that thought it was finished with stars. It is like a firefly in an empty field at night. It burns, alone, for its little while, and then it too fades, and the dark closes over it again. So the degenerate era is not a dead, static blackness. It is a slow, quiet, almost meditative time, lit by cooling embers and the occasional brief firefly flare, with vast silences between. If you could speed it up and watch it like a film, you would see the white dwarfs slowly winking out. Here and there, a brown dwarf collision sparking and dying. The whole thing growing gradually darker and stiller across spans of time, so long they make the Age of Starlight look brief. And underneath all of it, the galaxies themselves are coming apart. Gently, the way everything in this era happens. A galaxy is held together by the gravity of all its stars, but over enormous stretches of time, the dead stars within it jostle and swing past one another, and these slow gravitational encounters gradually fling some outward into the empty dark between galaxies, and let others sink inward toward the centre. Over time scales that dwarf everything we have discussed so far, the galaxies dissolve. Most of their dead stars are flung out into the void, scattered, alone, and the rest spiral down toward the great dark object that waits at the centre of nearly every galaxy. We will come to that object soon, because it is the inheritor of all of this, the thing that outlasts the embers themselves. But for now, simply hold the picture of the degenerate era, a universe of corpses, glowing faintly, scattered ever wider, cooling ever slower, in a dark that grows by tiny degrees more complete, trillions upon trillions of years passing, the white dwarfs fading toward black, the galaxies quietly unspooling into the dark between them. It is the longest twilight imaginable, and it is strangely peaceful. No catastrophe, only a slow and patient cooling, the universe settling deeper into rest, the way a house settles into quiet after everyone has gone to sleep. But the embers cannot glow forever, and here the story takes its strangest turn yet, because even the matter the embers are made of, the same kind of matter that makes up your hand, and this bed, and the air you are breathing, may itself have an expiry date. The atoms themselves may not be permanent. And if that is true, then even the cold dead stars are living on borrowed time. Let us pause the long journey here, in the middle of the embers, and come back to ourselves for a moment, because all of this immense cold deep time means nothing at all unless we set it beside something warm. So set it beside this, right now, tonight. Wherever you are lying as you listen, there is warmth, and air at a comfortable temperature, and somewhere nearby, almost certainly, a small light blowing, a lamp, a screen, the soft green dot of a charger, the line of street light under the curtain, small warm lights holding back a little circle of dark. We are so surrounded by them that we forget them entirely. But think about where that warmth ultimately comes from. Every bit of it traces back, in the end, to a star. The warmth in your home was made by burning something. The sun's light once grew, or by electricity that came from sunlight stored in wind or water, or ancient buried forests, or, somewhere up the chain, from the heat of the earth, which still carries the leftover fire of its making. We are creatures of the Age of Starlight, through and through. We are made of warmth that the stars provided. Every meal you have ever eaten was sunlight captured by a plant passed along. You are quite literally lit from within by stars. And that is the thing that the long dark future puts into perspective so gently. We spend this whole journey walking forward into a cooling, dimming universe, watching the great fires go out. But we are not in that future. We are here, in the warm, in the bright early morning of everything, in the one narrow window of cosmic time when light is abundant and easy and everywhere. We did not have to live in the embers. We got to live in the blaze. There is an old, simple human image that fits this perfectly. The campfire in the dark. Picture it. A small fire, a circle of warm gold light, and beyond it in every direction, an enormous night. The fire does not push the night very far back. The dark is patient and immense, and it is going to win in the end when the fire burns down. Everyone sitting around a campfire knows this somewhere underneath, and it does not ruin the fire. It is what makes the fire precious. The warmth means more, not less, because the dark is real and the fire is temporary. The whole universe is that campfire, and we are sitting around it now in its brightest hour. The dark beyond it is the deep future we have been walking through, the era of embers, and the longer eras still to come. And the fact that the fire will not last forever is exactly what makes this moment, this warm-lit moment, worth everything. There is something else worth saying here, quietly, before we go on. In all of the immense future we are exploring, all those trillions and quadrillions of years of cooling dark, there is, as far as we know, no one to see it. The era of life, of warmth, of creatures who can look up and wonder, is almost certainly confined to the Age of Starlight, this brief bright window we happen to occupy, which means that the universe's only chance to be noticed, to be loved, to be understood by anything at all is now, in the morning, by us, and by whatever else woke up in the light while the light was here. That is not a sad thought, it is close to the opposite. It means that you, lying there in the dark of an ordinary night, are part of the single brief era in which the universe gets to be witnessed. The embers will blow for ages, with no eyes to see them. The black holes will reign over an empty cosmos, with no one to know they are there. But the stars, the warm, bright, crowded stars, those have us. They have someone awake beneath them, even now, even half asleep, holding them in mind. The light is not wasted. Something is here to receive it. So when the long dark of the deep future feels heavy, remember the campfire, and remember which side of it you are on. You are not out in the cold ages, lost among the cooling cinders. You are here, by the fire, in the warm, in the light, in the only part of the whole vast story that has any brightness in it at all. And that is an extraordinary piece of luck, the most extraordinary there is. To exist is rare. To exist now, in the lit hour, is rarer still. Hold the warmth of that, the way you would hold a cup of something warm in cold hands. Let it settle into you as you lie there. You were born in the morning of the universe. You got the light. And now, gently, because we have warmed ourselves enough, we can go back out into the dark and follow the story all the way down past the embers to the strange, slow unmaking of matter itself. Because there is a question we left hanging at the edge of the firelight, and it is time, softly, to ask it. If even the atoms are not forever, then what, in the end, actually lasts? Here we come to one of the deepest and most uncertain ideas in all of physics. And because it is uncertain, I am going to be honest with you about exactly what we know, and what we only suspect. That honesty is part of the calm. We are not going to pretend to be sure of things that no one is sure of. The question is simple to ask. Is matter permanent? For most of human history, the answer seemed obviously yes. Things wear down, things break, things rot, but the underlying stuff, the atoms, simply rearrange. Burn a log and you have not destroyed its matter. You have only turned it into ash and smoke and gas, all of which still exists. The atoms endure. This deep permanence of matter felt like one of the bedrock truths of the world. But in the 20th century, as physicists built their theories of the smallest particles, a strange possibility appeared. The heavy particle that sits at the heart of every atom, the particle that makes up, along with its partner the neutron, almost all the ordinary matter you have ever touched, might not be perfectly stable. According to certain deep theories that try to unite the forces of nature, the proton might, very rarely, decay. It might, after an almost inconceivable length of time, simply fall apart into lighter particles and radiation and cease to be a proton at all. Now, how rare is rare? The theory suggests that a proton, if it decays at all, has a lifetime of something like 10,000 trillion years or even longer. The number is so vast that it is essentially meaningless to the human mind. To give you a sense of it, if you had a single proton and waited the entire current age of the universe, the chance of seeing it decay would be so close to zero as to be nothing. You would have to gather an unthinkable number of protons and watch them all to have any hope of catching even one in the act. And that is exactly what physicists have done. Shielded from the noise of the cosmos, they have built enormous tanks filled with thousands of tons of ultra-pure water, surrounded by sensitive detectors, all watching patiently for the faint telltale flash of a single proton falling apart. The largest of these is in Japan, an experiment that has been watching for decades. And here is the honest result. They have never seen it, not once. In all those years of watching all those countless protons, not a single confirmed proton decay has ever been observed, which means that as of tonight, proton decay is not a fact. It is a possibility. What the experiments have told us is only a lower limit. If the proton decays at all, its lifetime must be longer than about 10,000 trillion years, because anything shorter, and we would have caught it by now. So we genuinely do not know whether ordinary matter is eternal or merely extraordinarily long-lived. Both remain possible, and the future of the universe looks somewhat different depending on the answer, which is a remarkable thing, that a question about the very deepest future hinges on a flash of light in a tank of water that we have never quite seen. But let us follow the possibility gently, because it leads somewhere beautiful. Suppose the proton does decay on those staggering timescales. Then every atom in the universe is, very slowly, coming apart, and the cold dead stars, the white dwarfs and the neutron stars we walked among in the Era of Embers, are made of those atoms. So across spans of time even longer than the long twilight of the cinders, those dead stars would be quietly dismantling themselves from within, one proton at a time, releasing a tiny trickle of energy as they go. It would mean that a white dwarf in the deep future, long after its stored heat is gone, long after it should be a cold black cinder, would still be glowing, not from fire, not from leftover warmth, but from the faint, slow death of its own protons, a whole dead star, glowing with the power of a few household light bulbs, no more than that, spread across an object the size of the earth. The dimmest imaginable light, the last light that ordinary matter can make, the universe burning the very atoms of its corpses for one final, almost imperceptible glow. And then, when the protons are gone, when enough time has passed that even matter itself has dissolved, the cold dead stars do not merely go dark. They go away. They evaporate slowly into the lightest particles and faintest radiation, until there is nothing left where a star once was. The white dwarfs vanish, the neutron stars vanish. The drifting planets and the cold brown dwarfs and the scattered rubble of 100 trillion years, all of it gone, dissolved into a thin haze of radiation in an ever emptier dark. That is the end of matter as we know it, the end of anything you could ever stand on, or hold, or be. After this, the universe contains no atoms at all. But it is not empty even then, because there is one kind of object that does not need atoms to exist, one kind of structure that survives the death of matter itself, and inherits the whole dark cosmos for an age longer than all the others combined. The black holes are still here, and now, at last, they are alone. So we arrive at the deepest, longest, strangest age of the universe, and its rulers are the only things left standing, the black holes. You already met them earlier tonight, as the remnants of the most massive stars, and as the great dark hearts of the galaxies, but back then they were a minority. The universe was full of brighter, busier things, white dwarfs and red dwarfs, and all the glowing embers, and the black holes were just the quiet heavyweights in the corners. Now, after the death of the stars and the slow unmaking of matter, the situation has reversed entirely. Everything else is gone. The embers have evaporated. The atoms have dissolved. And the black holes, which needed none of that to survive, simply remain. The universe has become theirs. This is the black hole era. And to understand it, you have to set aside the dramatic way black holes are usually pictured. Forget the roaring whirlpools of light, the screaming matter falling in. Those belong to the bright young universe, where there was still gas and stars for a black hole to feed on. In the black hole era, there is nothing left to fall in. The black holes have eaten everything they are going to eat. They are not violent now. They are still. They are dark spheres of pure gravity, scattered impossibly far apart across an expanse of nothing, each one silent, each one alone. And they come in a great range of sizes. There are the small ones, the remnants of single massive stars, a few times the mass of the sun, packed into a region smaller than a city. And there are the giants, the supermassive black holes that grew at the centres of galaxies, some of them billions of times the mass of the sun, swollen further over the long ages by swallowing the dead stars that spiralled down into them, as the galaxies came apart. These are the great dark cathedrals of the late universe, the most massive single objects that will ever exist. Picture the black hole era sky, if there were any way to see it, which there is not, because there is no light, but picture it anyway, an almost perfectly empty dark, stretching in every direction far beyond anything we can call observable today, because the expansion of the universe has pushed everything so far from everything else, and in that immense emptiness, here and there, separated by gulfs that make the distance between galaxies tonight look like nothing. A black hole, just a region where the dark is somehow more complete, a circle of perfect nothing, bending the faint stray light of the dying universe ever so slightly around its edge, silent, patient, waiting. What is there to do in such an age? Almost nothing, and that nothing takes an unimaginably long time. The black holes drift, occasionally across spans of time that defy all description. Two of them, bound together since the death of their galaxy, slowly spiral toward each other and merge, joining into a single larger darkness with a ripple of gravity that spreads silently outward through the empty cosmos. But these events are rare beyond rare, separated by ages, and each one only makes the surviving black holes fewer and larger and lonelier. It is worth pausing to feel how long this era is, because it is the longest of them all by far. The Age of Starlight lasted 100 trillion years, and we called that unthinkable. The Era of Embers and the slow unmaking of matter lasted vastly longer than that, but the black hole era makes even those look brief. Written out is a 1 followed by so many zeros that there is no point in saying the number aloud, because no human mind, not the greatest that ever lived, can hold it. The black holes reign over the dark for almost the entire remaining life of the universe. Nearly all of cosmic time, measured from the death of matter onward, is this one long, dark, silent, patient age of black holes drifting alone. And yet, even here, the universe is not truly empty, and the black holes are not truly eternal. Because a black hole, the most permanent seeming object imaginable, the very symbol of forever, is, in the deepest sense, also temporary. It too is slowly going away. It is just so slow about it that it makes everything else we have discussed tonight look hasty. The man who discovered this was Stephen Hawking, and it is one of the most beautiful and surprising results in all of physics. A black hole, he showed, is not perfectly black. It glows. Unbelievably faintly, but it glows, leaking the very faintest trickle of radiation out into the dark around it. And that trickle, that almost nothing, carries away a tiny, tiny bit of the black hole's mass, which means a black hole is not gaining forever. Left alone in an empty universe with nothing to eat, it is, ever so slowly. The black holes are not the permanent rulers of the late universe after all. They are simply the longest lived of all the temporary things, the last embers in their way, blowing colder and slower than any ember before them, across an age so long it almost deserves to be called forever. But it is not forever. And one day, after a wait beyond all imagining, even the last black hole will reach its end. Let us follow a single black hole all the way to its end, because it is the quietest, slowest, gentlest death in the entire universe, and it is the last real event that will ever happen. The glow that Hawking discovered is strange in a way that matters enormously for how this ends. You would think a bigger object would shine brighter and disappear faster. With black holes, it is the reverse. The bigger a black hole is, the colder it is, and the more faintly it glows, and the longer it takes to evaporate. The ones a few times the mass of the sun are the warmest, and they go first. The great supermassive giants, billions of times heavier, are the coldest things in all of nature, far colder than the empty space around them, and they last the longest of anything that has ever existed. How faint is this glow? For a black hole the mass of the sun, the radiation it gives off is so feeble that it is colder than the deepest cold of space today, by an almost absurd margin. It would take you longer than the entire current age of the universe, repeated an unthinkable number of times, just to notice the black hole had lost any mass at all. This is not a fire. It is the slowest leak imaginable, a single drop escaping from an ocean once in an age. And so the evaporation takes time on a scale that finally breaks the language entirely. A black hole left over from a single star will take something like a 1 followed by 64, to 67 zeros worth of years to fully evaporate. The great dark cathedrals at the hearts of the vanished galaxies will take something like a 1 followed by 100 zeros worth of years. These numbers are not large in the way that 100 trillion is large. They are large in a way that has left the human scale so far behind that they are essentially just symbols for almost forever. But almost forever is not forever, and here is the lovely strange thing about how a black hole dies. For nearly all of that immense span, almost nothing happens. The black hole simply sits in the dark, leaking its impossibly faint glow, shrinking by amounts too small to picture, for age upon age upon age. But as it shrinks, it gets warmer. And as it gets warmer, it glows a little more, and so it shrinks a little faster, and so it gets warmer still. Having taken almost the entire life of the universe to get going, finally begins to accelerate. And at the very end, after all those uncountable ages of patience, the last tiny remnant of the black hole flares. Not a great explosion by the standards of the bright young universe, nothing like a supernova, but in the absolute silence and absolute dark of that unimaginably late age, it is a genuine event, a final faint burst of light and particles, the last gasp of the last black hole scattering out into the empty dark, and then the black hole is gone. Where it was, there is nothing. Just a little more radiation, thinning into the universal dark, like the last spark from a fire that went cold an eternity ago. Sit with that image for a moment, because it may be the single loneliest and most beautiful thing in all of cosmology, the last black hole in the universe, after a wait that makes the entire history of stars and matter and life look like the first. Instant of the first morning gives off one final faint flicker of light, alone, in a dark so complete and so old that there is nothing anywhere to see it, and then it too is gone. That flicker is, as far as we know, the last real event in the history of the cosmos. After the last black hole evaporates, there are no more structures left. Nothing dense, nothing bound, nothing that can collapse or merge or burn or shine. The universe has finally spent the very last of everything it was given at the beginning. Every star, every atom, every black hole, all of it has been converted, across ages beyond counting, into a thin and ever-thinning haze of light, and the lightest of particles, drifting in an endless dark. And the strangest part is that there was no drama to any of it. We tend to imagine the end of everything as a bang, a tearing, a catastrophe. But the real end, the one the physics points to, is the gentlest thing imaginable. A slow cooling, a patient fading, a long, long settling into rest, room by darkening room, until the last faint flicker of the last black hole winks out, and the universe at last is still. But even now, even after the last event, the story is not quite over, because something does remain in that final dark, not structures, not objects, but the universe is still there, still expanding, still containing the faintest scattered remnants of everything it ever was. And there is a name for what comes after the last event. The physicists call it the Dark Era. It is the final age, the one with no end, and it is where, very gently, we have come at last to the final age of the universe, the one that comes after every event, and I want to describe it gently, because despite its name there is nothing frightening here. The Dark Era is the most peaceful place in all of time. By now the universe has emptied itself almost completely. The stars are 100 trillion years gone. The dead stars and the planets and all ordinary matter have dissolved. The black holes, the last and most patient structures of all, have evaporated, down to the very last one, in its very last flicker. What is left is the thinnest imaginable scattering of the simplest things. A few stray photons of light, drifting alone. A few of the lightest particles, electrons and their mirror twins, the positrons, wandering separately through an immense and growing dark, and that is essentially all. And these last few wanderers are not crowded together. The expansion of the universe, which we have followed through this entire story, never stopped. So across the Dark Era, everything that remains is being carried ever further from everything else. The distances become so vast that a single electron might drift for an entire age without ever once encountering another particle. The universe becomes, in the truest sense, empty. Not empty like a clear night sky, which is full of stars and light. Empty like a single grain of sand alone in an ocean that keeps getting larger. There is a temperature to all of this, and it is the coldest thing there is. Throughout the whole life of the universe, the leftover warmth of the Big Bang itself, the faint background glow that fills all of space, has been cooling as the universe expands. Tonight it is very cold already, just a few degrees above the absolute lowest temperature that nature allows. But in the dark era, it keeps falling, lower and lower, approaching that absolute zero ever more closely, though never quite arriving. The universe becomes a vast, dark, all but perfectly cold, and all but perfectly empty space, with the faintest scattering of the faintest things drifting through it, ever further apart, ever colder, ever stiller. And here is the deepest strangeness of the dark era, the thing that makes it so different from every age that came before. In the dark era, nothing happens. And I do not mean that loosely, I mean it almost literally. An event requires a difference, a gradient, somewhere warmer next to somewhere cooler, something that can flow from one to the other. All the action in the history of the universe, every star that burned, every life that lived, every black hole that flickered out, was powered by such differences, by energy flowing from where there was more of it to where there was less. The physicists call the using up of those differences the growth of entropy, and it has been increasing steadily since the beginning. In the dark era, the differences are finally gone. Everything is the same, faint cold everywhere. There is no warmer and no cooler, no fuller and no emptier, nothing left to flow anywhere, and when there are no differences left, there is nothing to drive any change. This is the state the old physicists called the heat death of the universe, although it is really a cold death, a freezing into perfect sameness. Some call it the Big Freeze. It is the final equilibrium, the deepest rest, the moment when the universe has finished doing everything it will ever do. And because nothing changes, time itself begins to lose its meaning. Time, after all, is something we measure by change. A clock ticks, the sun moves, a heart beats, atoms vibrate. But in a universe where nothing happens, where there is no change anywhere to mark the passing of one moment into the next, what would time even mean? The hands of every possible clock have stopped, not because they broke, but because there is nothing left for them to measure. The universe simply is, in its final state, unchanging, forever, and forever has stopped being a length of time and become a kind of stillness. This is the true ending, as our current understanding paints it, not a bang, not a tearing apart, not a fire, but a slow, complete, and perfectly gentle settling into rest. The universe does not die in violence. It falls asleep. It dims, room by room, ember by ember, structure by structure, across spans of time that no mind can hold, until at last there is only the faint cold dark even, peaceful and still, with the last few wanderers drifting silently through it, further and further apart, forever. It is, in a way, the most profound silence imaginable. We began this series with the silence of the universe tonight, the strange quiet of a sky that should be full of voices. This is the other silence, the final one, the silence after the very last sound has faded, and there is nothing left anywhere to make another. And it is not a sad silence. It is the silence of a house after everyone has gone gently to sleep, the deep quiet that comes not from absence but from rest. That is the end of the story, as far as the simplest reading of the physics can take us. The dark era, peaceful and unending. But here is the honest truth, the one a careful guide has to tell you. We are not actually sure the story ends that way, because the map of the deep future is still being drawn, and just recently, the people drawing it found something that may change the ending entirely. Everything I have described tonight, the death of the stars, the era of embers, the slow unmaking of matter, the long reign of the black holes, the final dark, rests on a picture of the universe that we believe to be true, but do not know to be true. And the honest thing, the thing that lets you rest easy rather than taking any of this too heavily, is to remember how young our understanding really is, and how much of the deep future is still genuinely uncertain. Consider how recently we learned the most important fact of all. For most of the 20th century, scientists believed the expansion of the universe was slowing down, gently braked by the gravity of everything in it. The only question was whether it would slow to a stop and reverse, ending in a great collapse, or merely coast outward forever, slowing but never quite stopping. Those were the two futures on the table, and they were very different. And then, in the closing years of that century, astronomers measuring distant exploding stars discovered something that nobody expected and almost nobody believed at first. The expansion of the universe is not slowing down, it is speeding up. Something is pushing the universe apart, harder and harder, accelerating its growth. They gave that something a name, dark energy, which is really just a label for our ignorance, an honest admission that we have detected its effect without understanding what it is. And the discovery of it rewrote the future of the cosmos completely. It is the reason the galaxies will recede beyond seeing, the reason the dark era empties so thoroughly, the reason everything ends in that vast cold separation rather than in a warm collapse. So the most basic shape of the universe's fate was unknown to everyone, even the greatest scientists, until just a few decades ago. That should make us humble about the rest of it. We are very early in the work of understanding the deep future, and the map has been redrawn more than once already, and it may be redrawn again. In fact, it may be being redrawn right now. Because in the last couple of years, a great new survey of the sky, an instrument measuring the positions of millions upon millions of galaxies to chart the expansion of the universe with more precision than ever before, has produced a result that has the whole field talking. And I want to be careful with that word hint. The dark energy may not be constant after all. It may be changing. Specifically, it may have been stronger in the past and may be slowly weakening over time. Now, this is not yet a settled fact. It is a tantalizing signal, strong enough to be exciting, not yet strong enough to be certain, and scientists are properly cautious about it, checking and rechecking because extraordinary claims demand extraordinary evidence. It may firm up into a discovery. It may melt away as more data arrives. That is how science works at the frontier, in the honest uncertainty before the picture clears. But suppose, just suppose, it turns out to be true. Suppose dark energy is weakening. Then the future we have walked through tonight might not be the real ending at all. If the push that drives the galaxies apart fades over time, then the great runaway separation might slow. The universe might not empty itself quite so completely, or so finally. And in some versions of that story, if dark energy were to weaken far enough, the expansion could even one day stop and reverse, and the universe could begin, ever so slowly, to fall back together. A different ending entirely. Not an endless cold dark, but a long, distant, gentle gathering, a coming back together of everything that had spread so far apart. We do not know. That is the honest answer, and it is a beautiful answer, because it means the story of the universe's deep future is not finished, not on the page, and not in the sky. There are other possibilities too, stranger ones, that careful physicists take seriously. There is the faint chance that the very fabric of space could one day shift into a more stable state, rewriting the laws of physics in a bubble that spreads outward, though there is no evidence this is happening and the expected wait is beyond vast. And there is the deep idea that in an infinite stretch of time, even in the cold dark, random chance might, with almost unimaginable rarity, briefly gather order out of the stillness again, the faintest flicker of something from nothing, once in a span of time so long that the numbers we have used tonight are as nothing beside it. These are not promises, they are open doors, possibilities that remain because we are honest enough to admit how little we truly know about the farthest reaches of time. The map of the deep future has blank spaces on it still, marked with the oldest words on any map, the words that mean we have not been there yet. And that strangely is a comforting place to leave the long journey forward, not at a certain ending, but at the edge of the known, looking out into a future that is still partly a mystery, still being charted, still capable of surprising us. Whatever the true ending turns out to be, though, one thing will not change, and it is the thing worth carrying back with us, out of all this immense cold, deep time, into the warm, small room where you are lying right now. It is the answer to the question we started with: what remains in the end? So let us come all the way back, gently, from the farthest dark, and ask the question one last time, the simple question underneath this whole long journey. After the stars go out, and the embers cool, and the matter dissolves, and the black holes flicker away, and even the deep future hangs uncertain on a map still being drawn, what actually remains? And the answer, the real answer, is not a thing at all. It is not an object you could point to or hold. What remains is that it happened. Let me try to say what I mean, because it is the most important thing in this whole episode, and it is easy to miss. The universe will not always have stars. We have spent tonight watching them go out, but the universe will always, forever have had stars. That is a different statement, and it is an unbreakable one. No matter how dark and cold and empty the far future becomes, no matter how long the dark era stretches, nothing that happens later can reach back and undo the fact that once the cosmos was full of light, the stars burned. That is now a permanent feature of reality, fixed and safe, beyond the reach of any darkness. The dark that comes after cannot unhappen the light that came before. And the same is true of everything warm and bright and brief that lived in the Age of Starlight. It is true of the earth, green and blue and full of oceans and weather and life. It is true of every creature that ever opened its eyes in the morning of the universe. It is true of every person who ever loved another person, every hand that ever held another hand, every quiet, ordinary evening like this one. None of it lasts. All of it ends. But all of it, every bit, will always have been. The universe will forever be a universe in which those things once were real. This is what the deep future teaches, if you listen to it gently rather than fearfully. It does not teach that nothing matters because everything ends. It teaches the opposite. It teaches that because everything ends, the fact that anything happened at all is precious beyond measure. The light was not cheapened by the dark that follows it. The light was made rare and beautiful by it, A thing that lasts forever can be taken for granted. A thing that happens once, in the brief bright morning of an immense and patient cosmos, and then is gone. That thing is a treasure, simply for having been. You are one of those things. You happened, in the entire history of the universe, across all the eras we walked through tonight, the long age of starlight and the longer age of embers, and the immense age of black holes, and the endless dark era beyond. In all of that, there is exactly one narrow window when a person like you could exist, could be warm, could be loved, could lie in a quiet room at night and think about the stars. And you are in it, right now. You made it into the lit hour. The odds against that are so enormous that there is no honest way to write them down. And yet here you are, awake in the morning of everything, holding the whole long story in your mind. That is what remains, not the matter which dissolves, not the structures which evaporate, not even the light which fades. What remains is the fact, permanent and untouchable, that there was light and warmth, and a universe that, for one brilliant era, was full of stars, and that something was here to see them. The far future is not a tragedy waiting at the end of the world. It is the vast dark frame around a small bright picture, and the frame is what makes you see how bright the picture is. We do not live in the leftovers of something better. We live in the best of it. The lit window, the campfire at its highest. And nothing that comes after, no cold and no dark and no immensity of empty time, can ever take away the fact that we were here for it, together in the light. So when you think about the death of the last star, as we have tonight, do not let it weigh on you. Let it do the opposite. Let it make this ordinary night, this warm bed, this quiet dark outside the window with its thousands of patient stars still burning, feel like the rare and precious thing it truly is. You are living in the Age of Starlight. You are living in the only part of the story with any light in it at all, and you are awake to notice. There is one more thing, and then we will let the night close over us and sleep. We have spent this whole journey looking forward into the dark that comes after the stars. But there is a dark that came before them too at the very beginning, before the first star ever caught fire. And that earlier dark was not an ending, it was a beginning. The same physics that lets us trace the universe forward to its last faint flicker also lets us trace it backward to the first light, to the moment the very first star broke the very first darkness. And that, the story of where the first light came from, is where we will go next. But that is for another night. Tonight we have come a very long way, all the way to the end of time and gently back again, and now it is time to rest. Let the great numbers fall away. You do not need to carry them. The 100 trillion years, the eras of embers and black holes, the immense cold dark at the end of everything, set them all down. They are real, and they are out there waiting patiently in the deep future. And they do not need you to hold them up. They will keep without you. Keep only the small warm thing we found in the middle of all that dark. You are here, in the morning of the universe, in the brief, bright hour when the stars are lit. That is the whole of it. That is enough. The cosmos spent its first 13 billion years getting ready, forging the atoms in dying stars, scattering them across space, gathering them into worlds, until at last on one small blue world, in one narrow window of warm and lighted time, something woke up that could look at the sky and understand a little of what it was seeing. That something is you. You are the universe in its golden hour, awake and warm and briefly, beautifully here. Outside your window right now the stars are still burning. Every one of them is a furnace pouring light into the dark. And they will go on doing it for billions of years, long after this night and this small worry and this passing day are forgotten. There is no hurry in the sky, the lights are not going out tonight. The Age of Starlight has barely begun, and you are in the warm heart of it, exactly where? Of all the moments in all of time, it is best to be. So let your breathing slow, and let the day go. Let the great dark future drift to the edge of your mind, not as a fear, but as a vast and gentle quiet, the deep stillness of a house where everyone is finally asleep. The universe will get there, in its own unimaginably patient time, to that final restful dark. But not for 100 trillion years, not for ages upon ages upon ages. Tonight the fire is high, and the room is warm, and the stars are all still here. Whatever remains, in the end, when everything else has faded, is the fact that there was light, and that you were part of it. That cannot be taken. It is already true, and it will always be true forever, beyond the reach of any dark. So rest now. You have earned it, traveller. You went all the way to the end of time tonight, and you came home safe, to your own warm bed, under your own bright stars, in the golden morning of the only universe there is. Sleep well. The stars will keep watch. They have a very, very long time before they need to rest. And when you are ready to drift out again, we will go back to the very beginning, to the first dark and the first light, and find out where the very first star came from. Until then, sleep. The fire is warm, the night is long and kind, and there is so much light still left to spend.
you.